Hey kids, Mr. Joseph here. In this video, I'm going to show you how to draw Lewis electron dot diagrams. And this is an example of one over to the right here. And I'm going to show you what that means. Okay, so in this presentation, we're going to first talk about valence electrons, atom dot diagrams, positive ion dot diagrams, and then finally negative ion dot diagrams. All right, so we're going to start out with the vocabulary definition of valence electron. And this is an electron in the highest occupied energy level of an atom, which is the outermost ring on a Bohr model. So let's look at an example of that. So how many valence electrons does a carbon atom have? Well, if we draw a Bohr model, it looks like this. And the outermost electrons are those right there. And you can see they're 4. So it's the number that's all the way over to the right on the electron configuration. All right, so that's pretty simple, right? So let's practice these. How many valence electrons does each atom of the elements to the right possess? Go ahead and pause the video while you practice that. Okay, so here's the answers. How many valence electrons does oxygen have? Well, 6. It's the outermost electrons is that number to the right. Lithium has 1, and neon has 8. Okay, there we go. So let's talk about electron dot diagrams. And we're gonna talk about 3 different types of electron dot diagrams. And the first is the electron dot diagrams of neutral atoms, such as calcium, gallium, and phosphorus. And then we're going to do the electron dot diagrams of ions. And that would include positive ions, which are cations, such as calcium and rubidium. And then also the dot diagrams for negative ions. And these are anions. That's the name for negative ions. And the names for negative ions actually end in "ide." So this is actually a phosphide ion and a bromide ion, even though it's from an atom of phosphorus and starts with an atom of bromine. So that's something to remember. So let's do the dot diagrams for neutral atoms first. So what is the electron dot diagram for a lithium atom? Well, what we do is we write the symbol down for the lithium atom, and then we look at the valence electrons that lithium has. And we simply put a dot to represent that valence electron along the side of the lithium atom or symbol. And we make sure that we keep the electrons lined up on each side of the symbol. That's what these purple lines are for. It's kind of silly to have that for one electron since it's just one electron, but you'll see what I'm talking about in the next example. So how about electron dot diagram for a carbon atom? Now this has 4 valence electrons. And when we place the valence electrons around the symbol like this, we need to make sure that we put them on each side of the symbol before we start filling them in next to each other. So for example, for carbon, your electron dot diagram, you're going to put those 4 electrons on each side of the symbol, pretending that there's a line on each side like this. All right. And now let's look at an example of an electron or an atom that has more than 4 valence electrons, such as oxygen. So we're going to write the symbol down. We see that we have 6 valence electrons, and we're going to write the electrons along the edges of the symbol again. And we're going to write them along like this. And then the last 2 electrons, we're going to place right next to the previous electrons so that we've got them lined up in pairs like this. You might begin to realize that what's the maximum number of electrons that you can have in an electron dot diagram? And the answer is 8. So for example, neon. Neon, we're going to draw the valence electrons, which is only 8 of them. I mean, only, that's the maximum you can have, valence electrons. And again, we're going to draw them right along the side, going in a clockwise pattern like this. They're all going to match up. And there we go. That's the electron dot diagram for neon. So let's practice this. Draw the Lewis dot diagram, electron dot diagrams for these atoms to the right. And pause this video when you do that. Okay, let's find out the answers to these. So we've got potassium, sulfur, and aluminum. And we have 1 valence electron for potassium. We just pop that baby right next to it. Sulfur has 6 valence electrons, so it looks like this. And then aluminum has 3, and so we've got 1 on each of 3 sides. All right, so we've done the Lewis electron dot diagram for neutral atoms. And now we're going to move on to the positive ions, the cations. So first we're going to have to talk about something called the Octet Rule. And this means that atoms react by gaining or losing electrons so as to acquire the stable electron structure of a noble gas, usually 8 valence electrons. So on the periodic table, which of these do you think are the noble gases? It said, look at this, it says usually has 8 valence electrons. So which atoms usually have 8 valence electrons? See if you can see what that is on the periodic table. Just take a look. Now in your head, think about that. And if you said this column over here, then you were right. There's only one exception. Helium at the top there only has 2 valence electrons. And that's because the first shell is filled up. Remember, the first shell gets filled up after 2 electrons and then moves on to the next level. That's what we learned with the Bohr atom. Okay. So let's look at how we can draw the structure of a sodium ion, keeping this in mind. Okay, you'll see what this means with the Octet Rule. So the first step in drawing an ion Lewis dot structure is to start with the Lewis dot structure of the neutral atom. So the sodium atom would be this, right? We learned how to do that. The second step is to determine how many electrons will be added or removed. And then we're going to remove it or add to it. So if we look at sodium, we have an electron configuration of 2-8-1. And the nearest noble gas, the closest noble gas, is neon with an electronic configuration of 2-8. So how do we get from 2-8-1 to 2-8? Do we add an electron or we take one away? And you can see that the valence electron there would be removed in order to get to the neon electron configuration, okay? All right, so finally, we're going to place brackets around the new symbol and place a superscript on the symbol based on how many electrons were changed. So we took away an electron, and so that means that there are more positive things in this atom than there are electrons, or negative things, because the number of protons didn't change. Those are the positive things in the atom. But a number of electrons did. 1 electron left. And so that means we have more positive than negatives. And so that means we put a positive charge on there. If 2 electrons left, we would put a 2+ on the symbol. Okay? And that's how you do a positive ion. So we've done the positive ions. Let's take a look at negative ions. So let's do a Lewis structure of an ion, a chloride ion. And it's chloride, which means that it came from a chlorine atom. Remember, negative ones are going to have an "ide" on the end. And I know that we haven't decided whether this is going to be negative or positive yet, technically. But, you know, we kind of know. So we start with, again, the Lewis dot structure of chlorine. It looks like this. And now we're going to find out why it would gain an electron. So determine how many electrons will be added or removed. Let's look at the nearest noble gas again, and that would be argon. From 2-8-7, we're going to go to 2-8-8. And how do we do that? Well, it's by gaining an electron. So we gain an electron, and we've put another one there. Now we're going to take that, and we're going to do the same thing we did as we did with the positive ion. We decide what we're going to put for the charge and we gained an electron, a negative thing. And so we're going to put brackets around this, and we're going to put a negative next to it. Okay. All right. So we're going to practice now. So we're going to practice doing a potassium ion, a fluoride ion, a nitride ion, and a calcium ion. Okay. So go ahead and pause the video and try to do this. Okay, let's look at our examples and our answers for these examples. And here they are. So the potassium ion, it lost an electron. The fluoride ion, it gained 1 electron. The nitride ion, it gained 3 because nitrogen started with only 5 electrons. And it gained 3 electrons. It became 3 negative. And the calcium ion lost 2 electrons to become 2 plus. Notice that the positive ions here don't have any electrons showing around them because they lost electrons. They still do have valence electrons, but in an electron dot diagram for an ion, we don't show that. And then the negative ions have a complete octet, or 8 valence electrons around them. So that's a pattern that you should be able to recognize. And that is how you do this. If you have any questions, just go ahead and ask me. And have a great day.